For the last decade, the default infrastructure answer has basically been cloud first, Kubernetes probably, and then good luck to whoever has to operate the thing after the architecture diagram gets turned into real life. And to be fair, the cloud solved a lot of real problems. Nobody wants to go back to waiting on hardware, filing tickets for VLANs, or discovering that the one person who understood the SAN is on vacation. But there is another side of this now. Cloud bills are getting harder to explain. Kubernetes platforms are getting harder to maintain. Data sovereignty is becoming a real business requirement. And a lot of teams are quietly looking at all of the layers that they have built and asking a pretty reasonable question. Is this actually simpler? Because sometimes the thing that was supposed to reduce operational burden just moves the complexity somewhere else into Terraform, into Helm charts, into networking, into managed service glue, into a platform team that is now responsible for making 15 different abstractions feel like one coherent system. And that is really what this conversation is about. Not cloud is bad, not bare metal is back, everybody grab a screwdriver. More like, what happens when teams want more control, more predictable cost, better performance, and less platform sprawl without going back to the old school pain of managing infrastructure by hand. I'm Brian Teller from Teller's Tech, and this is Ship It Weekly. Welcome back to Ship It Weekly, where I filter the noise and focus on what actually matters when you are the one running infrastructure and owning reliability. Most weeks, it's a quick news recap. In between those, I do conversation episodes with people who are building platforms, running infrastructure, organizing events, and thinking through where this industry is actually headed. Today is one of those conversations. I'm joined by Jake Warner, founder and CEO of Cycle.io. Cycle is an infrastructure platform that lets teams run containers and virtual machines across bare metal, cloud, private cloud, and hybrid environments without trying to turn every company into a full-time platform engineering shop. And I like this conversation because it gets into a topic that a lot of people are thinking about right now, even if they are not always saying it out loud. A lot of teams are tired. Not lazy, not anti-cloud, not anti-Kubernetes, just tired of the amount of complexity that has piled up around modern infrastructure. You start with a simple goal. Run the application, scale it, deploy safely, keep it reliable. Don't spend a fortune. Then suddenly, you have Kubernetes clusters, node groups, disruption budgets, autoscalers, Terraform modules, managed services, IAM policies, GitOps controllers, observability agents, service meshes, secret systems, and a Slack channel where somebody asks why the platform is blocking delivery. And somewhere in the middle of that, people start wondering whether there is another way to think about infrastructure. In this conversation, Jake and I talk about why some teams are moving back towards private cloud and bare metal, but not in the nostalgic racking and stacking servers was awesome kind of way. More because of cost, performance, data sovereignty, compliance, and wanting more ownership over the stack. We also get into what people still misunderstand about bare metal, why some teams want VMs and containers living together, where Kubernetes is still the right answer, and where an opinionated platform might be a better fit than giving every team every possible knob to turn. There is also a good thread in here around failover versus active-active systems, stateful workloads, why application-level replication often beats platform-level magic, and what it really means to make raw infrastructure feel like a cloud-like resource. And towards the end, we talk a bit about AI workloads, GPUs, hype cycles, and why the most bleeding-edge teams are not always the same teams that want an opinionated platform. So if you work around DevOps, SRE, platform engineering, cloud infrastructure, Kubernetes, private cloud, or you are just starting to wonder whether your modern platform has become a very expensive junk drawer, this one should be worth your time. All right, let's jump in. Today I'm joined by Jake Warner. He's CEO and founder of Cycle.io. We're going to be talking about private cloud, bare metal, and why a lot of teams are quietly exhausted by platform complexity. Jake, thanks for joining me.
Thanks for having me.
Give me your thesis. Why are teams pulling back towards private cloud and bare metal again?
So, for most of the people watching this podcast, we all knew that bare metal was really sexy, a decade ago, right? 15 years ago. The cloud made it super easy to move away from bare metal. It solved the big complexity that came into, um, I mean, we all know how hard it was to get a bare metal server online, get it configured, do it at scale. In the early days of Cycle, I'd always say, anyone can deploy one or two servers. But when you need to start automating 100 servers, that's when the problems get really complex, right? I'm guessing most people listening to this podcast are completely aware of that. But with what we built with Cycle, our goal was to simplify that process so that way you could have companies that were able to own their bare metal, etc., and still provision it like a cloud-like resource. And the reason why we kind of did that and why we see companies coming back to bare metal is number one, cost. Hyperscalers ended up, they made it really easy. But we've all seen hyperscalers just continue to increase costs. And once you get locked into that ecosystem, your costs kind of only go up. So that's number one. Number two is about data sovereignty concerns. I think, especially with a lot of the geopolitical issues that we're seeing in the world right now, most of the companies that we've been working with are companies that are saying, whether it's compliance reasons or they have customer demands, maybe is the right term for it. We have companies that are coming to us and saying, we cannot be on a US owned hyperscaler. Even if geographically that infrastructure is sitting over in Europe, we need to, because of the US Cloud Act, we have companies that are saying we cannot be on US owned infrastructure. So I think that in terms of private cloud, in terms of bare metal, it all kind of comes back to number one, cost, number two, data sovereignty and compliance. And then the third item there would be performance. And for a long time, I think people kind of gave up the performance that bare metal would give because the ease of the cloud outweighed the performance you got from bare metal. But fast forward to today, where you have platforms like what we've built that can make bare metal a cloud-like experience on top of bare metal. It allows those organizations to go back towards performance, lower their costs, and own more of their stack in the process.
So along those same lines, is there like a common misconception you see that people have regarding bare metal or on-prem in general?
Oh, absolutely. So, as recently as, I mean, it happens all the time. But we were doing a demo back in November, and this was with a large company over in Denmark, and they were one of the early companies to adopt AWS. And this company, they were looking at getting away from Kubernetes. They were using EKS, and the reason, the main reason they were coming to us was data sovereignty issues. They had customers that were saying that they needed to not be on AWS to be able to continue to be customers of that company. And during that demo, one of the requirements, because I kind of posed the question, like, are you interested in just getting off of AWS, or are you also interested in adopting bare metal as part of this? And the company was like, no, we don't want to talk bare metal. Like, we don't want to be responsible for maintaining hardware. We don't want to be responsible for setting up all the networks and all of those things. And you could tell, again, very technical team, but they had spent so much of the last decade plus in the cloud that they were just kind of used to that. And we did the demo, and 3/4 of the way through, I was like, hey, we're talking about all these DevOps terms, we're talking about containers, infrastructure, etc. What if I do the rest of this demo and do it on bare metal, but not tell them until afterwards? And it was kind of like a game to me. Like, I had someone kind of challenge my thoughts on, the ease of bare metal. And so we got to the end of the demo and showed my cards, and I was like, oh, by the way, like the infrastructure we just deployed and the containers we just deployed, that was all bare metal. And the company immediately did a 180, and they're like, okay, you've sold us. Let's talk about bare metal now, because they realized it was one of those things where, kind of to the 3 points that I just made about cost, data sovereignty, and performance, the main item for them was data sovereignty. But when they realized that now they could have that cost and performance conversation at the same time, and it wasn't necessarily exclusive, it was kind of eye-opening. So I guess back to the question that you asked, which is, what is the big misconception? There's a lot of people that have spent much of their careers in the cloud. I mean, again, it's been the main way we've been deploying for a decade now. That because of that, they've kind of, what's the whole cliche? Going through the forest or the mountains, or you're missing, I don't remember the cliche, but the point is that when you're so focused on something, you kind of miss some of the advancements that are happening in the process.
Yeah, for sure. I mean, so I am one of those people where I was early days. I worked at a colo facility, racking and stacking, servers. Very, very different world now than it was back in the late 90s, early 2000s. Yeah, very different as far as management of those colo facilities. Completely different now.
With those colo facilities, it's really interesting because so many of the people that I encounter that are bare metal friendly and like ready to return to it are the people that were racking and stacking back at that time and the early cPanel days, and they're like, I want to get back to that because they kind of miss that. Like it means something to them. But then you have this whole generation kind of in the middle where cloud was the beginning of their career. So as you talk about rack and stacking, like that is dear to me as well.
Yeah. So when you say turn any infra into a private cloud, what does that mean for a DevOps team day two?
So with Cycle, the way we've kind of approached things from a philosophical standpoint, I'm kind of anti infrastructure as code. Like in Cycle, we call it environments as code. The idea is that you have a thin but defined line between infrastructure and everything that's going to run on top of that. And so in Cycle, we have what we call environments as code, which is called stacks. And that's where you define your, load balancers, containers, everything that you are going to be deploying over and over and over. But then infrastructure, we treat as just a pool of resources. So I guess maybe that's kind of a throwback to the racking stacking days that we were just talking about, where you're taking cPanel and trying to pack, these hosts with as many things as you can. And so with Cycle, the idea is that, you bring bare metal, you bring VMs, whether it's in the cloud, or we have some companies that are running Cycle on top of VMware. The idea is you bring raw compute, Cycle will automatically join it into a mesh, and then that becomes kind of your private cloud. So it can be hybrid infrastructure, multi-cloud, fully on-prem, or a mixture of all of the above. And then applications that you're building, your networks, etc., and just overlay on top of that. So again, you have this thin but very defined line between infrastructure on one side and your applications on the other.
So one of the things that I believe I read on, I believe it was on your website, you say no DevOps army required. What does that mean in practice?
So I've been writing code for, I don't know, probably 22 years now. I guess there's the common saying that the best DevOps engineer will automate themselves out of a job. Whether that's true or not, up for continuous debate. But I've been writing code for a long time, and it seemed like any time it came to actually deploying that, whether it was back in the cPanel days or with Docker, Kubernetes, etc., that was always the thing that slowed me down the most. And while I always loved working with infrastructure, I didn't really like maintaining it. That was always a thing. Like, I mean, sure, getting it up and running is fun, right? I mean, it's why I think most of us get into it. The first days of setting up infrastructure and, placing an order to buy a new bare metal machine, that's exciting, right? But, 3 months later, no one wants to maintain it anymore. And so the goal of Cycle was how can we build a platform that allows developers to do the things that typically you would need a DevOps engineer to do? And I'm not saying that, to fully replace DevOps engineers, but in many cases, companies that are coming to us are companies where it's very engineering heavy. So, like 10 developers to every DevOps engineer or a greater ratio. We have some companies that are 25 to 1, etc. And those seem to be the places where we do best. And one of my favorite components of that is when we have developers that are deploying things on top of the platform that aren't really DevOps engineers at all, and they can't tell you how they did something, but it works.
Yeah.
And, that's one of the things that is nice about that. So yeah, so no DevOps army is required is just that philosophy. Like, how do we empower developers to do what they need to do without having to become DevOps experts as part of that?
So talking about mixed workloads, can you give me like a real world workload mix? Like why do teams want VMs and containers living together? Why would they want that?
There's probably hundreds of different potential reasons. One company that I was helping earlier this morning are running all of their different microservices and containers. That's just how they built their platform. But then due to a whole bunch of legacy, they're a company that's been around for I think 18 years. They have a number of applications that are built on top of .NET and require Microsoft SQL and things like that. For them, all of their newer microservices are running instead of containers, but for them being able to have those legacy applications running inside a Windows VM sitting on the same infrastructure, on the same network, where to the containers, they don't know they're talking to a VM and vice versa. It's just fully abstracted. So everything just sees network endpoints, but it allows companies to not have to change everything for adoption. So that's one. And I guess another use case is we have some companies that are in regulated industries and things like that, where for certain applications they need true virtualization for isolation as opposed to just C groups and the isolation that comes with containers.
Yeah. I feel like as an industry now too, everybody wants to containerize every service and makes sense in a lot of cases, but I've also found that there are cases where putting it inside of Kubernetes or some sort of container orchestration layer doesn't always make sense. We're just doing it because that's the phase right now. It just seems like, yeah, every trade show I go to too, it's pushing this idea of containerization, which again, microservice layers make sense. There's certain applications though where I don't think like putting bridges and stuff inside of a container makes sense, especially when you're dealing with like services that can't be disrupted. It's a issue that I've come across a lot in the last like year or two.
Yeah, I mean, I would say that I'm probably on the opposite side of that. I containerize everything that I possibly can. But I mean, I also built a platform for it, so kind of aligns with my belief there. But yeah, I containerize everything to the point that on cycle, every virtual machine is also actually a container. And so that way we have container layer, we have containerized hypervisor, and then you have your VM sitting inside of that. And so the nice thing about that is that as we roll out new versions of the hypervisor, given that it's containerized from that perspective, we're able to kind of roll out different versions of that hypervisor as users opt into it. So the kind of little benefits from that. Um,
So that's interesting. So let's talk, I guess, a little bit more about the containerization aspect. In Kubernetes, I'm dealing with PDBs, pod disruption budgets. I'm dealing with maybe Carpenter if I'm on AWS. So I'm having this scale up and down nodes as needed. And then if I'm dealing with spot instances, I could have disruptions to workloads. How does Cycle handle that orchestration of services?
So there's two ways that Cycle approaches that. Number one is that in general, I believe that the idea of failover is a terrible idea. And I've seen so many times in my career where, you set up all these processes for failover and then things fail to fail over when things go wrong, right? And so with that, the idea that failover is kind of high risk. It's also along the same kind of philosophy that less moving parts is better. So inside of Cycle, when we talk about like stateful workloads and things like that, in general, the approach that we have is to run everything in active 100% of the time. So that way, if one side goes down, you're perfectly fine. Like when that side comes back up, you'll recover. Now, if you need to evacuate, to another host, you can do that too. But there's a reason why Mongo and so many of these modern database technologies have their own replication built into it. And I guess maybe that's a little bit of a tangent is it bothers me so much when platforms try to automate storage replication as opposed to letting the application that knows how to replicate it properly replicate it. And so in Cycle's world, we try to, everything is active. We try to move things as little as possible. And then if you are deploying a container and you mark it as stateful, the platform will treat that container separately, almost like a VM. It'll almost treat it like a VM. So that way its data will always move with it. Like we will, like instead of like creating like a volume claim in Kubernetes, we will create an attached LVM, like a raw LVM, and then migrate that as needed. And if you need to scale up, we'll scale up, but we're going to rely on the underlying application to know how to replicate that data. Because again, if we're talking about like Mongo as an example, being able to have a collection level locking as you do as migrations and things like that, as you have elections happening, like great. Why should a platform try to do that?
In general, what would be like a best bare metal use case right now, given the trajectory of the industry?
I mean, I think that for companies that are trying to reclaim ownership of their stack, bare metal is a great way of doing that. At that point, you're just consuming raw compute. The different services that you're kind of locked into are significantly less. I mean, I guess it depends on what provider you're going with and things like that. But for the most part, your pricing is going to be significantly more stable. For example, we just signed a partnership today to be announced soon that includes 100 terabytes of bandwidth per server on a 10 gig link. And, when you start talking about 100 terabits, or sorry, 100 terabytes of bandwidth, per, VM or whatever, AWS, you're talking about a huge bandwidth bill. Uh,
Yeah.
so the fact that some of these bare metal providers are including 100 terabytes per server just out of the box with normal pricing is wild. And maybe I should take my earlier response back and instead talk about performance and performance density, right? Because like we as a company, we've been buying some more bare metal recently we're getting ready to launch a European control plane. So we're buying more infrastructure for that control plane. And the fact that we were able to buy physical machines with 24 physical cores for $280 a month with dual 10 gig links and 100 terabytes of bandwidth included and 192 gigabytes of memory each, and RAID RAID 1 with terabyte NVMEs. Like, I mean, that same specs would be, I mean, I don't know the exact number, but I'm guessing probably 3 to 4 times over at AWS, and then you'd still have the virtualization
Yeah.
overhead on top of that.
What do you think is the reason for that? Do you think that these colo or server providers are trying to compete with that market, or what's the reason for the discrepancy in pricing? You think is it just because we're paying so much for the control plane at AWS?
That's my theory. I don't actually know. Like, it's wild that you can buy that level of performance
Yeah,
for that price. And yeah, yes, there's one of the cons that you typically get from most of these kind of bare metal providers today. One of the cons is that from a network perspective, you have way less pops, right? So your latency from a network standpoint can be meaningfully higher, where if you're using AWS and GCP, I mean, you'll have great latency to almost anywhere in the world, where some of these bare metal providers, you might get 1 or 2 pops. Now, granted, there are some like Equinix and Megaport that's what they do, and they can still give you, a really solid network. So there's pros and cons, but I don't know if having 10 plus pops, at GCP is also worth a 3x price increase on compute. I don't know
yeah,
if that's the reason why, but I think the network is like the network resiliency is probably the one con to bare metal today.
yeah. I guess it matters what your workloads are if you're latency sensitive, but yeah, like if you're doing high traffic bidding applications where you need to bid for creative or something, I could see you needing to have that low latency for that. But I don't think that most people, especially if you're serving websites or you're serving a web app, I don't think for the most part it would matter. But also, I mean, level 3 is in Northern Virginia in the same area as, you could probably buy colo space. Again, I'm sure Northern Virginia area is expensive just because DC metro area, but you could probably buy colo servers in that area competitively against AWS's rates as well.
Well, it's kind of funny that you mentioned that. Because of AWS's presence there, we have so many companies that when they're switching to bare metal and using cycles as part of that process, we have companies that specifically need bare metal in that region. And it's like, hey, you can deploy bare metal anywhere in the world. And they're saying, no, 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 no. I need to connect to Supabase or some other service running on top of AWS. So even though they're trying to get off of AWS as a cloud provider, they still need to be in proximity to it, because so many of the services they're communicating with are still direct, sitting right on top of that infrastructure. So we have companies that did initial test deployments and they were deployed to somewhere around New York City or somewhere to, Atlanta, and they would find out that that extra 12, 15 millisecond latency was too much for them. And so it's weird how there seems to be such a, and it's only on US East 1. We don't have any other companies that are like, oh, US East 2 or US West 1 is where I need to be. But for whatever reason, US East 1, we just have an extreme number of companies that are like, I need to be close to that. And it's kind of coincidental because that's the one that always has an outage, or at least
Yeah.
it seems.
Yeah. And it's the control plane for the rest of the services. So what I have found is when US East 1 goes down, if you have services that are in US West 2, maybe like an auto scaling group that needs to scale up, new instances, it's not able to because it's not able to reach out to the control plane, which lives in US East 1. Yeah. There's
Yep.
still marriage there as much as they maybe try to say that they're isolated. They're not.
Yeah, that is something I've absolutely noticed as well. When US East 1 goes down, you just have to assume that everything else is also impacted.
Okay, so speaking about cycle versus Kubernetes, what do you think that Kubernetes gets right, and where does it become self-inflicted pain?
So with Kubernetes versus cycle, and when is kind of a better fit for one versus the other, it really kind of comes down to the needs of individual companies from a customization perspective. For companies that are really, as I mentioned earlier, kind of engineering heavy, that are like, hey, we're mainly developers, we're very microservice heavy, we might need object storage, or like the requirements that they have are pretty, let's say, commoditized, right? They need some disk, they need some, object storage, they need kind of the primitives. That's where Cycle really shines. But at the same time, if you have companies that are like, hey, we need people to run on very specific hardware with very specific kernel drivers and things like that. That's where Kubernetes is a better fit from that perspective, because with Cycle we ship a standardized OS to everyone. We don't provide SSH access. That OS is made to be as dumb and as tiny as possible. It's 40 megabytes in size, so that means that naturally it's going to be kind of limited in terms of what it can do. Like, our goal is to target 80%, right? But if you have like really specific infrastructure you need to run, or supercomputing applications, or some of these big AI models that people are buying a whole bunch of really sophisticated infrastructure for these days, Cycle today is not built for bring anything. We are built for more of bring your typical x86 server, with a few drives in it. We'll get it up and running. We'll get you what you need. So it all comes back to whether do companies need just basic primitives and they don't want to be DevOps, or do they have a very specific list of requirements that extend from network to hardware to maybe the host OS that those nodes need to run. People who are coming to Cycle are looking for an opinionated answer. It's why most of the companies that are on Cycle today are companies that left Kubernetes for Cycle. Like, they went that route, they tested it. Many of them were on Kubernetes for years before they decided, like, I think that it's natural for all of us techies to want to play with new technologies, but at some point people are like, you know what, I don't want to play with all of the bells and whistles anymore. I just want it to work.
Yeah.
And it's something that I kind of talk about often is, most people, when they get their first smartphone, or at least for me and most of my friends as we were growing up, your first smartphone is an Android, right? And I know I'm probably about to piss off a whole bunch of people, but your first, typically your first phone is an Android phone because you want to customize it, you want to play with it, you want to make it
You want it to be
yours.
yours. Yeah.
Yeah,
Yeah.
exactly.
Yeah.
But eventually people are like, I don't really care about that anymore. I just want a phone that works. I don't want to, let me change my background and I don't care. And then they switch to an iPhone. And so that's kind of what I've kind of always said about Cycle. Like, companies, they're going to go play with Kubernetes. They're going to go play with Ranch, or they're going to go kind of test out, the latest and greatest. They want something where they can change every variable. But at some point, it no longer becomes about changing variables and playing with the latest and greatest of everything. They just want to get back to what they want to build. And so that's where we built Cycle for companies that are like, yeah, just give me a standard opinionated platform and I'll just work with that. And so, yeah.
Yeah, that makes sense. So, okay, wrapping up, what's one thing you'd do first if you had to monetize on-prem or hybrid without blowing up the team?
This is going to go back to a conversation we had, 10 minutes ago, but containerize, right? Like,
Mhm.
I'm a big fan of containerizing everything. It makes applications typically way more portable. And if your goal is to chase portability, so that way you can kind of move to whether it's VMs or bare metal or on-prem. I mean, I guess that's bare metal too, or mixture. Being able to standardize containers is, I think why I'm such in such a favor of them. Yeah, I mean, I think that would be my first step. I think that would absolutely be my first step from that standpoint. Now, if the question is, what if I'm already containerized and now I'm trying to like go towards bare metal? I think the next step there is look at your dependencies. If you're in a hyperscaler already and you're using things like Lambda and S3 and things like that, your next step is kind of to decide what services I'm going to try to replicate on top of bare metal. What am I going to be okay having still in the cloud? And do the primitives that I need allow me to be on bare metal? Because again, if you are tightly integrated into Lambda and some of these other things, bare metal might not be the best fit for you. But if you're just running a whole bunch of containers, then you're kind of in a good spot. So assuming you're containerized, I think then the next part of that is evaluating what third-party services you need and whether you can bring those in-house or whether you're okay with those staying on the cloud.
Yeah. Have you noticed an increase in AI workloads and people building containers around AI specific workloads using Cycle?
So it's kind of interesting for how much you log into LinkedIn and Reddit and things, and everything's about AI. So many of the companies that are on Cycle today, like, yes, a number of them do have some AI component in what they're doing, but I think we only have one or two clients that are running like true models with GPUs on top
Actual
of
models
Cycle.
locally. Yeah, I didn't mean like API calls to OpenAI, but yeah,
Yeah, yeah, yeah.
like actual modeling locally. Yeah.
Yeah, so Cycle out of the box supports all NVIDIA data center class GPUs, and so that's one of the drivers that we keep up to date. So we support that, but we were hoping that we'd have more AI focused applications on top of the platform today. But I think that it's one of these kind of interesting things where it's kind of like with IoT and then crypto. And now AI, like yes, there are hype waves, and I'm not saying that AI is you know you know, equivalent to IoT or crypto or things like that. But as we see these hype waves happen, we always see people who kind of love bleeding edge technology chase them, right? Like so many of my friends that were like really gung ho on crypto are now the same people that are really deep into, AI. And then the next thing that comes out, they're going to chase that as well. Like it's what they do. And those people typically are the same people that like changing all the the dials, and they like playing and tweaking. And so that's where I think those people, they don't want an opinionated platform like Cycle. They want something where they can customize everything. It's kind of like the book of Crossing the Chasm, right? Cycle's there for the majority in the middle. They're like, hey, no, I just want to run stuff. I want to build stuff. But then those super early adopters that are always chasing new technology, they want more customizability than Cycle will give them. And I guess to an earlier point, that's where Kubernetes probably makes more sense for them. But when applications kind of become more standardized and they just want to run them, then that's where Cycle starts to win.
Makes sense. What is Cycle? Why would someone choose Cycle? What would be a reason for choosing Cycle?
Yeah, so for an organization that is really engineering heavy, a company that wants to spend more time focused on building versus maintaining, and when I say building versus maintaining, I'm talking about building the actual applications, the platforms, the services, etc., and less on maintaining the host OS, the host kernel, the underlying infrastructure. That's where Cycle really shines for these organizations, especially teams where they have really talented developers, but these developers really don't have interest in becoming DevOps engineers as part of that process is kind of where Cycle shines.
Makes sense. Okay, so wrapping up, where can people read more about you, find out about you, read more about Cycle? Where should they go?
Yeah, so to learn more about Cycle, you can visit our website, which is cycle.io. We also have a Slack community that we have a lot of developers and DevOps engineers that hang out in. That's slack.cycle.io. And then for people who want to maybe learn more about me, I guess linkedin.com/in/Jake Warner. Like it's kind of weird to hand out to use my LinkedIn as the primary source, but I think I keep it more up to date than anything else I do these days.
That makes sense. I'll also put links for all of that in the show notes as well, so make it easier.
Sounds good.
Awesome. Well, thank you, Jake, so much for coming on and telling me more about Cycle and containerization. Really appreciate it.
Yeah, really, really appreciate you having me on, Brian. Really enjoy the conversation. Always fun to be able to, as you mentioned earlier about racking and stacking, meet people of like mind in terms of how we got to where we are today.
Awesome. Thanks. All right. That was my conversation with Jake Warner from Cycle.io. My biggest takeaway from this one is that the cloud versus bare metal debate is kind of the least interesting version of the conversation. The better question is, what are you actually trying to optimize for? Because sometimes the answer is cloud, sometimes it is Kubernetes, sometimes it is managed services, all the way down because your team does not have the time, people, or business reason to own more of the stack. But sometimes the answer is different. Sometimes the problem is cost. Sometimes it is performance density. Sometimes it is data sovereignty. Sometimes it is compliance. Sometimes it is latency. Sometimes it is the fact that your developers just want to ship software, and your platform team is slowly drowning in a pile of abstractions that were supposed to make everything easier. That is the part I think is worth paying attention to. A lot of teams do not necessarily want to go backwards. They want to go back to owning the parts that matter without reintroducing all of the old pain. And that is a much more useful framing than pretending there is one correct infrastructure model for everybody. I also like Jake's point about opinionated platforms, because as engineers, we love flexibility. We love knobs. We love knowing that technically, if we really wanted to, we could customize every piece of the stack. But there is a cost to that. Every knob becomes a decision. Every decision becomes something to document. Every exception becomes something to support. And eventually, the platform that was supposed to help teams move faster becomes another system that needs its own platform team just to keep it sane. That does not always mean opinionated platforms are always better. If you need very specific kernel drivers, specialized hardware, deep customization, or you are doing weird edge case infrastructure work, then Kubernetes or a more flexible platform may absolutely be the better fit. But for a lot of teams, especially teams that mostly need containers, VMs, networking, storage, load balancers, and a sane way to deploy applications, there is a real argument for fewer choices and better defaults. And honestly, that is probably where a lot of infrastructure conversations are heading. Not everything should be cloud, not everything should be Kubernetes, not everyone should move back to bare metal. More like what complexity is actually helping us, and what complexity are we just carrying because the industry told us this is what modern infrastructure is supposed to look like. I'll have links to Jake, Cycle.io, and their Slack community in the show notes. If you enjoyed this conversation, follow or subscribe Ship It Weekly wherever you listen to podcasts. It helps the show, and it makes sure you get both these conversation episodes and the weekly DevOps, SRE, platform, cloud, and security news recaps. You can also find the show notes and links over on shipitweekly.fm. Thanks for listening, and I'll see you later this week.